This is Chapter 15, Section 1, Properties of Sound, by Jenifer Blancas
and Stephanie Gomez.
So, Stephanie, what is sound?
Well, Jennifer, sound is created by air molecules colliding in the form of waves. These collisions among the air molecules cause pressure variations coming from the source. So, Jennifer, now that we know what sound is, how will we describe sound?
Well, the frequency of the wave is the number of oscillations in pressure each second. Because the motion of the air molecules is parallel to the direction of the motion of the wave, sound is a longitudinal wave. In air, the speed of the wave is dependent on the temperature. In other mediums, the speed of sound differs. In solids and liquids, it is greater than gases. So, Stephanie, what makes a certain sound loud?
Well, Jennifer, amplitude is the measure of the variation in pressure along the wave. In humans, sound is detected by the ear and interpreted by the brain. The loudness of a sound, as perceived by our sense of hearing, depends primarily on the amplitude of the pressure wave. So, Jennifer, what is pitch?
Marin Mersennus and Galileo first connected pitch with the frequency of vibration, and it can also be given a name on the musical scale. Loudness, as perceived by the human ear, is not directly proportional to the pressure variations in a sound wave. The ear sensitivity depends on both pitch and amplitude. Also, perception for pure tones is different than it is for mixtures of tones.
Frequency in hertz times the Greek letter lambda in meters equals velocity in meters per second. This equation can be arranged to form lambda equals velocity over frequency.
For our first demo, we took our noisemaker and slid it from one end of the lockers to the other. As the noisemaker slides through, you can hear the sound get louder as it gets closer to the camera and quieter as it moves away. Is that good?
The Doppler effect was named after Christian Doppler, who first came up with the idea in 1842. He learned that sound waves would have a higher frequency if the source was moving toward the observer, and a lower frequency if the sound was moving away from the observer.
A commonly used example of the Doppler effect is a train. When a train is approaching, the whistle has a higher pitch than normal. You can hear the change in pitch as the train passes. The same is true with sirens on police cars and the engines of race cars. The Doppler effect doesn't just apply to sound. It works with all types of waves, which includes light. Edwin Hubble used the Doppler effect to determine that the universe is expanding. Hubble found that the light from distant galaxies was shifted toward lower frequencies to the red end of the spectrum. This is known as a red Doppler shift, or a redshift. If the galaxies were moving toward the Hubble, the light would have been blue shifted. Doppler radars also help meteorologists learn about possible tornadoes.
Please look for The Physics of Music to continue learning about sound.
Thank you for watching and hope you enjoyed!